Pressure shocks. Pressure shocks from many collapses result in an audible noise very characteristic to cavitation. The sound used now in the video has been recorded in an experimental setup similar to the one in the animation. But how does it look like when cavitation bubbles are formed and collapse in detail? We can see the formation and the collapse of cavitation bubbles with a diameter of approximately 9 mm in slow motion. In real time, this process takes about 4 milliseconds, and it is a spectacular physical event. Because liquid water occupies many thousand times less volume than vapor, the bubble implodes. It first assumes a ring shape. Shock waves and a strong microjet are the result of a collapse. Let's go through the whole process again. If the local pressure decreases below the vapor pressure, water evaporates. A cavitation bubble is forming, is growing larger, and is transported with the flow to a region with a higher pressure. The bubble stops growing. If a local pressure exceeds the vapor pressure, vapor condenses, starting from the bubble's wall. Its surface starts to break down at its weakest spot. A microjet forms and pierces into the bubble's opposite surface. The bubble is now collapsing. The bubble becomes a torus and disintegrates further. The microjet continues to flow in the liquid and can hit a wall. Through its concentrated impact, even high-strength material can be damaged. The implosion releases energy in a very short time concentrated in a very small spot. If the microjet hits a surface, it damages the material by a localized, short-term overstraining. The material starts to evolve microcracks, and later material can break off. We show a few examples of damage in pump impellers kindly provided by the Swiss pump manufacturer Herney. A brand new impeller to the left in comparison with an impeller having been continuously exposed to cavitation during 6 months, another impeller with damage from 12 months operation in cavitation, and one from 24 months. The new impeller shows the geometry as it should be under normal operation without cavitation. After 6 months of operation under cavitation, material has been eroded in the center of the wheel. The respective areas are highlighted with grey color. The impeller blades are undamaged. After a year of operation under cavitation, the damaged geometry has a different shape, and therefore the flow has a different pattern. The collapsing cavitation bubbles cause material break-off at the top edge of the blades. After 2 years, the blades have been eroded completely, which makes it impossible for the pump to function. In this video, we have shown the basic mechanism leading to the formation of cavitation bubbles, which reduce the flow of water. We have also seen the spectacular collapse of cavitation bubbles, leading to noise and damage even to high-strength material. Systems have to be designed.